Hi everyone, and welcome back to Scaled Factory. This is the final part of our three-part series, where we have been creating a constant velocity joint from design to 3D print. In part 1, we modeled the CV joint in Fusion 360, and in part 2, we designed this custom base to go with it. If you missed those videos, be sure to check them out. Today, we are taking designs into Bambu Lab Studio for slicing, 3D printing them, and finally, showcasing the printed parts in action. Let's get started. Okay, now we are on Bambu Lab Studio. Before starting the printing, I want you to show some key points on printing movable objects. As you know, an FDM type printer is working by putting melted layers on top of each other, basically. So while doing that thing, because the filament itself is still hot and melted, it's possible to have them fused together while they're supposed to be separate pieces. In our model, it's a real problem because we want the socket and the pin is moving freely. They won't be fusing each other. There are different ways to achieve that thing. From printer to printer, it may change, but I want to show the basics of this process. So easiest option is just to have them as separate objects. In that case, the printer will print them separately, so there won't be any problem about fusing. But what if we want to print them together? Let me show you some tricks about that thing. I will leave them here and I will import it once again. Okay, this is our model. I will try to slice it. So in my settings, the supports in tree form is open, but they are limited to be started from the plates, not on the model. So let's check what's going on here. If we'll go to these layers where the socket and the pin interface is built, as you see, now that blue part in the center actually is the first layers of the pin. So it's an overhang piece. It means that there is no supporting structure beneath it. So kind of it's just put on the air without a support. It won't work in real life because it means that these things should fly to not to be fused with the socket. So what we'll have here, that these blue parts actually will be in touch with the layer beneath them, with the socket. So our socket and pin will fuse at that point. As you see, even if they're not touching each other, there's enough clearance between them. Because they touch and fuse at the bottom, they will be one piece. So if we are lucky, that fusing will be really weak and we'll be able to break it with our hands. But in such a delicate model, actually, it's really small. That thickness of that wall of the socket is about a millimeter, so it will be a really thin and fragile model. Probably we will break it in our hands. So while printing that kind of movable parts that's supposed to be separate and movable freely, we should think about this fusing problem. It has two aspects. Sometimes fusing happens because there's not enough clearance between the points. Even there's no support problem. These walls may just fuse to each other. It's one problem. It depends on our nozzle width, our layer height and sometimes, and our tolerances. Our printer also is working for that thing. Actually, there are so many tweaks and small fine-tuning points to uh, prevent that problem from occurring. But the other thing, this overhang problem, as you see here, sorry, it on that side. It's not about printer. It's the geometry itself. Uh, Actually, Slicer is saying that this part is supposed to fly. There's nothing holding it in the air. It's just staying there without a support. So we know that when the printer puts that layers, that lines in here, they will fuse with the part beneath them. So what can we do? Let's import once again. Actually, I want to print all of the side, all three styles to show the results to you. Okay, now we have the same piece. Let's rotate it upside down. So now what's changed? It's still the two parts are sitting on each other, on top of each other. But difference will be the support parts. As you see, the socket itself is a kind of cut sphere, and these parts on the bottom will be on the air. And socket itself will have a bottom here, but it will work like an arc that each layer will be partly sitting on the layer beneath it. So there will be no piece that is supposed to fly actually, like on the other side. And socket itself won't be sitting on the pin, but instead these parts will be supported by the support structure. Now let's see. As you see, the socket is supported from this side. So the weight of the socket will be on the support trees, support structures. And each layer above will be just sitting on the layer below, as you see. So even if there will be a bottom piece, it won't be it won't be supposed to fly on top of nothing. Actually, it will be supported by the parts of the socket that layer beneath them. So in that way, it has much more chance to not fuse. In any case, depending on the printer, depending on your settings, and sometimes it's just your luck that parts may fuse. I know many times I was printing some things, and at the same time that two identical parts that's printed together end up with different results. Some of them fused, some of them was working fine. But in any case, I want to show you to my setup. I have Bambu Lab P1S with zero point 0.4 millimeter nozzle, and my general settings are like that. Layer height is the minimum that I can achieve with that printer. I'm choosing seam positions random, but aligned will just work actually. Uh, it's it's the way that I choose it. It's not something special about the model. These settings, actually almost all of them, is about that fusing and not fusing selection. Usually, these are the fine-tuning parameters. But in our case, that sting on each other and fusing problem, whatever you do in here, it won't solve the problem, as you see in this model. For strength, nothing special actually. Most of them are the default values. Speed too, I'm using PLA filaments. For support, okay, these supports are three style supports. Style is default and threshold angle is 30. And I'm choosing on build plate only option. Otherwise, it may put some supports on the model itself. Sometimes it works, but this model has a really huge interface that's not reachable from outside. If it tries to put supports there, our model will be ruined. So it's not possible to remove that support structures from there. And in others, actually, Beam is enabled and in autotype in my settings and nothing else. That's it. So let's print all of them and check the results. So here are the parts. This one, as you see, that socket part was just destroyed on the plate. Probably I should clean it. And these are the second one. The pin was on top of the socket and it's printed on this orientation. As we talked about earlier, it's just fused together. And actually it feels really strong and I don't want to destroy it by pushing it a little bit more. Probably it's just fused on top of the pin between socket as we guess while checking it on the slicer. And this one is our third model and socket was on top of the pin and you can see it's moving freely. Actually this model, because I want it to be removable and printable separately, it's not that hard to remove the pin from socket and put in the place. So actually our other pin that's printed separately will just fit here, as you see. It's moving freely. It's a really delicate model, it's really lightweight, and actually I don't know it will be strong under load. But Meanwhile, I print another one with a little bit thick dimensions. The socket itself was a little bit thicker, about 2 millimeters, and the small pins on the spherical pin on the center is stronger. Actually, it's a little bit more heavy duty one in that case. And these are the bases. Bases are just have size suitable to put it inside and remove it. Sorry, turn on that direction. The same problems about fusing and things is uh, we can also have that kind of problems on printing base. But as I told you, these are more general problems. It's better to have more tolerances if you are working with different printer or you don't know what you'll have in another process with your own printer. And the other one. And here it is, our completed 3D printed CV joint with a custom base. It's been so much fun bringing this project from design to reality. Hope you enjoyed following along with this series. If you give this project a try or create something similar, I'd love to see your work. Share it in the comments or tag me on the social media. Don't forget to like this video, subscribe to Scale Factory, and hit the notification bell to stay updated on future tutorials and projects. Thanks so much for watching, and I'll see you in the next video.